solution is based off of question 4A on the spring 2020 LAM exam. And as you can tell, if you look at this, it actually becomes complicated really quickly because we have a matrix of like a 4x4 matrix, and we need to go 3 years, and we need to use the equivalence principle and use a discount rate to find out what we should establish our premiums at. And so you start, my coworker and I'm going to show my Excel formula right here. My coworker and I, we initially wanted to just use brute force, and that ended up being like 64 combinations. That wasn't going to work. My coworker, he suggested maybe we could just use some matrix multiplying, and we couldn't figure out how to do it until we looked at the Infinite Actuary solution. So this solution's different from theirs. In fact, they have actually even a better solution on theirs, a more accurate one. But this one matches the model solution on the SOA, and so we're going to go with this. I just wanted to explain what to do, like what the main trick on how to solve these quickly. So here we have our initial matrix, and then what you do to get your next one down, to square it, all you need to use is this formula right here, matrix multiplier, MMULT. And then so you just highlight this one 2 times, and then you get it squared right there. And then for the third one, all I didn't type in the pound key right there. You just click on, like you're trying to highlight this one right there, and it'll just put like D15 pound. And then you put in your next one up here, and there you go. So this is the third one. So what does this mean? What this means is that we start at the active state, right? We start at active state in time 0. We have a probability of 0.9 in staying in the active state. What does this 0.822 mean? Well, that means that we ended up in the active state in time 2. And then this one means we stayed in the active state at time 3. So it doesn't matter what path we took to get back to the active state, but it just means we arrived at the active state at time 3. So I should word it that way. Right here, I have it discounted. This ended up not paying off as well as I was hoping to. I thought I could just do a shortcut and just make 3 more matrices of like discounting it by the 10% here. And then I have my premiums right here. So we know at time 0, we immediately pay 1. And then what was the probability that we arrived at this state discounted back? Well, it's just 0.9 divided by 1.1. And then we just add another premium, which is what's probability we ended up in active state in time 2. It doesn't matter what trail we took. And so that was this number right there. And then you multiply it by P, because we don't know what premium is. The disability benefit, we did something very similar. So we pay 100, and then the probability is discounted that we paid this disability benefit. And then this death benefit, it's a little bit more complicated. In fact, it's wrong. I highly recommend that you look at the Infinite Actuary, and that's a really good source to use. The Infinite Actuary, I highly recommend it. They explain it so well in their videos. Anyways, so this one I just used the death benefit, and then you have to subtract the prior year's death benefit, because you don't get a return on premium multiple times, you just get it once. And so that's what's going on there. And then this premium right there, I just solved for P, moved the P over, like I subtracted the 0.06 from the 2.49, and then I divided it, and so there you go. The answer, this answer right here, which is not completely true but follows the SOA model solution, is 5.655. So that's what you should charge on your premiums.